So today we're going to look at question number 2 from the 2013 free response part of the exam, okay? And it's dealing with a particle in motion, okay, moving on a straight line, and they're giving you the velocity function, and the position of the particle is given by s of t, and you know that s of 0 is equal to 10. So we know the starting position is at 10. Okay, so let's go ahead and answer question or part A. Find all values of t in the interval 2 to 4 for which the speed of the particle is 2. So the speed of the particle is the absolute value of the velocity, okay? That's speed. So we want to set that equal to 2 and solve it, okay? So let's go to our paper and let's write that out. Okay, so in part A, I went ahead and wrote down the velocity function, okay? And so what we want to do is we want to solve the absolute value of v of t, and we want to know when this is equal to 2, okay? So I'm going to put the velocity function into my calculator, okay? And we're looking for where 2 is less than or equal to t and less than or equal to 4. So we're looking between 2 and 4, okay? So I'm going to go to my graphing calculator and we're going to solve this on that. So from our calculator's home screen, we want to press y equals, okay? And then we want to select the absolute value function, which is alpha window and then number 1. And then we're going to type in that velocity inside the absolute value because that will be speed, okay? So we have -2 and then plus and then parentheses and then t squared plus 3t and then raised to the 6/5. You could do 6 divided by 5 or 6/5 like I'm doing. And then make sure we come out of the exponent, okay? And then minus, and then x cubed, okay? Or t cubed. Okay? And then we're going to set our y2. We want to know when this is equal to 2, okay? So we're going to set that equal to 2. We're going to go to our window, and we only want to look between 2 and 4, right? So we're going to set this to 2 and this one to 4, okay? And x scale by 1s is fine, or 0.5 would be fine too. Y-min, let's make this, let's make it like go from like -10 to 10. And you don't really know until you just jump in and try and see what are the settings, okay? Let's do that, the y scale is 1. And let's go ahead and graph and see what we get. Actually, that was a pretty good choice, okay, from -8 to 8. Okay, so right here we want to find, so this is my speed function, right? Okay, so the blue is the speed, and so the red line is when it's 2. So right here we find this intersection, okay, right here and here. So there's 2 times when the speed is exactly 2 in the interval 2 to 4, okay? So we're going to go second and trace for the calc menu, and we want to find the intersection. Okay, so first curve is the speed, okay, and then when it's equal to 2, and then guess, we're going to get that one on the left side first, okay? All right, so we have 3.128, okay? So we're going to record that value, okay? And then we're going to go and do the other one, okay? All right, so let's go second. And you want to record this on your paper. I'm going to go back and record it, okay? And then second, trace for the calc menu again, and then number 5. And then we want to get this one right here, okay? So I would just want to move closer to that one and just press enter, enter, and enter, and we get 3.473, okay? So I'm going to go back and I'm going to record this on our paper. Okay, so what we got for this was t from their graphing calculator. T was about 3.128, and also when t is about 3.473. And those are the 2 times between 2 and 4 in which this happened. Okay? All right, let's go to part B. So for part B, we want to write an expression involving an integral that gives the position s of t. So use the expression to find the position of the particle at time t equals 5. So there's 2 parts to this, okay? The first sentence and the second sentence. Okay, so we were given that the initial position, right, s of 0 is equal to 10. So if we integrate velocity, we're going to get position, okay? So we want to integrate from 0 to t, okay? And that would give us the position for any time value, okay? All right, so we'll go back and do this. So for part B, we know that if we go with S of t, okay, that's going to equal S of 0 plus the change, right? And the change would be the integral from 0 to t of v of x and then dx, okay? Because that's the t that's represented right here, and that's where we want to stop the integral, okay? So these t's need to match, okay? And then we have to use a dummy variable in here, okay? All right, now, so that's it. We could change the S of 0 to 10 because on our paper we knew that. So we could rewrite this as S of t is equal to 10 plus the integral from 0 to t v of x dx, okay? And if you want to know S of 5, okay, S of 5 would be equal to 10, what we started with, plus the change. And this is the change, right? So the integral from 0 to 5 of v of, and because you change this to 5, you could actually change this back to v of t, okay? All right. I'm going to leave it as x, though. So v of x dx, okay? So this we're going to put into our calculator, okay? And so, and then we'll have what S of 5 is. Okay, and then we're going to probably round this. Okay, so we're going to go back to our calculator and do that. Okay, so from our calculator, we want to go back to y equals, and I want to take the speed off, okay? So I'm going to delete. I'm going to be right on top of this absolute value, and I'm going to press delete. And what will happen is it takes away the absolute value, because now we have the velocity function, and that's what we want, okay? So y1 is now the velocity function, not the speed function, okay? All right, and so I'm going to go to my, back to the home screen, okay? And we're going to type this in, 10, okay? And then plus, and then we want to integrate, so alpha window, and then number 4 for function integrate, and we want to go from 0 to 5 of our velocity function. Okay, that's why I wanted to change it and get rid of the absolute value, okay? We want our velocity function, so alpha trace, and then select number 1, because that's where we stored our velocity function, and then at x, okay? And we press enter, and we get negative 9.207. So we'll go back and record that, and that's the position of the particle at t equals 5, okay? All right, let's go back to our paper and we'll record. Okay, so this came out to be negative 9.207 from our calculator, okay? And that's it for that one, okay? Let's go to part C. So for part C, we want to find all times in the interval 0 to 5 at which the particle changes direction, okay? So how do we know when the particle changes direction? It's when the velocity function changes signs. So where the velocity function goes from, on our graphing calculator, from below to above the x-axis, or vice versa, okay? From above to below or below to above, okay? So we're gonna graph the velocity function between 0 and 5 and see what we get. Before we go to the graphing calculator though, I do wanna do this, okay? We wanna solve for v of t is equal to 0. We need to solve that, okay? Because that will tell me where the velocity is 0. And then if it changes signs at that value, okay, then we know it changed directions, okay? So let's go ahead and go to the graphing calculator and solve this from 0 to 5, okay? Because we do have this 0 less than or equal to t, less than or equal to 5. And we're going to look in that interval for where this happens. Okay, so we want to, from our home screen, okay, we want to press window. And we want our x min to be 0 and our x max to be 5. X scaled by 1. Probably y min to negative 10 to 10 is good too. And I just realized I said earlier negative 8 to 8, but it was negative 10 to 10. Okay, and then for y equals, we want to press this. We want to change this from being 2 to being 0, because we want to know now, we want to know where the velocity is 0. Okay, and then let's graph that and see what we get. Okay, so from 0 to 5, okay, before this time value right here, right, where the velocity is 0, and right here, it's changing. So the velocity down here was negative, and then the velocity up here is positive, right? So it changed directions at this t value when it stopped, okay? And then same thing over here. It changed, the velocity was positive, and then it became negative, right? So right here, the velocity changed signs, okay? So I want to find this intersection. So we'll go to second, calc, and then number 5. And then let's get close to this one on the left. And we'll press enter, enter, and enter. So at 0.536, the particle changed directions, okay? And then let's find this other one. So we'll go second, alpha 5 intersect, and we'll get over close to this one. And press enter, enter, and enter, okay? And then 3.318, okay? It happened there too, okay? All right, so let's go ahead and record those on our paper, okay? And that's it for part C. So when we solve this, we got t is approximately 0.536, and then also t was approximately 3.318. Okay, and the question was, when does the particle change directions, okay? So the particle, we write this up, the particle changed directions at t is approximately 0.536 because v of t changed, and it changed from negative to positive. At that time value. So at t is approximately 0.536, and the particle changed directions. You could write 2 sentences for this too. Okay, so change directions at t is approximately 3.318 because v of t changed directions, or changed, not changed signs, or changed from, let me get my, change signs, okay, would be okay too, okay? Changed from positive to negative at t is approximately 3.318, okay? And that's answering it, okay? All right, and giving the answers with the justification that it asked for, okay? All right, let's go to part D. So for part D, they're asking, is the speed of the particle increasing or decreasing at time t equals 4, okay? This is asking, it, in essence, is it speeding up or is it slowing down, okay? Because speed increasing would be speeding up, and speed decreasing would be slowing down, okay? So to know if something's speeding up or slowing down, you got to look at 2 things. You got to look at the velocity at that time, and you also need to look at the acceleration at that time, okay? All right, and then depending on what the signs are of those, you can tell if it's speeding up or slowing down, okay? So let's go to our calculator, or let's go to the page, and we'll do the write-up, and then we'll figure this out, the values on the calculator, okay? All right, so let's go to our page. So what we're gonna have to find is v of 4, and we're gonna need to know what that is. So we're gonna need to put 4 into the velocity function that they gave us to figure this out, okay? Now we also need to find the derivative at 4, which is equivalent to the acceleration at 4, to figure out what this is, okay? And then once we figure out these two values, then that's going to allow us to determine if the speed is increasing or if the speed is decreasing, okay? All right, so let's go to that right now. Let's go to our calculator and put these in. So we're on our home screen now, okay? And I'm going to clear out what we have, okay? And then what I want to do is I want to find the velocity at 4. Well, we have in our y equals, okay, we have the velocity function, that's y1. Okay, so what we can do is go to our home screen and just type in alpha trace and select number 1. And so this is like v of 4, right? So we want to type in parenthesis and then dot x. We want to type in 4, right? And then close the parenthesis. Okay, now so that's the velocity. It's negative 11.456. Okay, so let's go ahead and record that on our paper, and then let's then put in the derivative. Okay, so that would be alpha window, and then 3 for numeric derivative. Okay, so we're going to take the derivative with respect to x of y1, our velocity. Okay, so alpha trace number 1. And then we want to find this, the derivative at 4. And this gives us negative 22.296, okay? So let's go back to our paper and record these two values. Okay, so from our calculator, we got, for the velocity at 4, we got negative 11.476. And then we got for our acceleration, which is also the derivative, we got negative 22.296. Okay, so what do we know? Okay, so the velocity is negative and the acceleration is also negative. So when they're the same signs, that means it's speeding up, which in this instance would mean the speed is increasing, okay? So we would say the speed is increasing at t equals 4 because v of 4 is less than 0. It's negative, right? And, okay, a of 4 is also less than 0, okay? And that's how we know the speed is increasing or it's speeding up, okay? That would mean the same thing. All right? Okay, that's it for the number 2 question for 2013, okay? Let's go on to our next problem and we'll do that one, all right? Okay. Okay, so today I'd like you to do a question from the AB exam, free response exam, and so I want you to take out number 20 or 2013, the AB area volume, okay, and I want us to answer question number 5, okay. So they're giving you a graph, okay, and I'm thinking I want you to do these because I'm thinking they're going to ask you to do this on the AP exam this year, okay, at some point, okay. Because they actually took this off the AB part, okay? So I'm thinking they're gonna have it on the BC part, all right? Okay, so if you look at this, all right, this one right here, it can't be the cosine curve, okay? This is the quadratic right here, okay? So this bottom function right here is f of x, okay? And they want to find the area of r, okay? And the intersection here is at 0 and here at 2, and you can just get those off the graph, okay? But this top function is the g of x function, okay? And then this bottom function is the f of x function. Okay, so I want to find the area of R. Okay, so we're gonna have to do top minus bottom, and we're gonna have to integrate from 0 to 2, and we would just go vertically, right? That'd be the easiest way to do it. Okay, so let's go ahead and do that right now. Okay, so we're gonna need to do this by hand. Okay, but the integral, it's gonna be the integral from 0 to 2. Okay, and the top curve is g of x, so it's gonna be g of x minus f of x dx. Okay, so this is equivalent to the integral from 0 to 2, and then g of x is the 4 cosine of 1/4 pi x. Okay, and then minus, and then it's going to be the 2. So I'm going to need parentheses because I'm subtracting 2x squared minus 6x plus 4. Okay, and I'm going to put a bracket around the entire thing, and then dx, right? Okay, so this would be the integral from 0 to 2. Okay, I'm going to do a u substitution here, right? So u, actually, I'm going to come over here and write my u. U is going to equal 1/4 pi x, okay? So 1/4 pi x, then du would just simply be 1/4 pi. And then dx, right? Okay, so I'm going to need a 1/4 pi, right? So if I have a 1/4 pi or pi over 4, I'm going to also have to multiply by 4 over pi, okay? So 4 over pi, okay, times pi over 4, pi over 4, whoops, I put 4 over 4. Okay, and then times, and then the 4 cosine of 1/4 pi x dx. And I'm breaking this into two integrals, okay? And then minus the integral from 0 to 2 of the 2x squared minus 6x plus 4 and then dx, right? And you wouldn't have to put parentheses around this because anything between the integral and the dx is what you're integrating, okay? All right, so this is going to be my u, right? And I'm going to need this, okay, this pi over 4 and the dx to make up my du. So this 4 over pi and the 4 are going to come out, and that's going to make 16 over pi. So this is 16 over pi. The integral, and I'm going to hold off on the 0 to 2 because I'm going to make my u substitution right now, okay? And so my pi over 4 and the dx make up my du. This 4 came out, so it'd just be cosine of u. So cosine of u du. Okay, now these limits of integration are going to switch to u values, okay? So this one's going to be 0 still, right? Because when I put 0 in here for x, it's just going to be 0. Okay, and then when I put 2 in, that's going to be 2/4 pi or pi over 2. Okay, and then minus, okay, and I'm just going to write this again, 0 to 2, 2x squared minus 6x plus 4 dx. Okay, so the derivative of sine is cosine, so the integral of cosine is sine, right? So this is 16 over pi sine of u evaluated from 0 to pi over 2 minus, okay, I'm going to put a bracket on this one, okay, and then minus, and it'd be 2x cubed over 3 minus 6x squared over 2, and then plus 4x, and we're going to evaluate that from 0 to 2, okay? All right, so then this, I'm going to slide over because I'm going to need some room here, okay? So this is equal to 16 pi sine of pi over 2 minus 16 over pi sine of 0. I'm going to put that in bracket. Minus bracket. Okay, now I'm going to put 2 in here. I'm going to also simplify at the same time, okay? So this would be 2 times 8. So 2 times, because 2 cubed is 8, so 2 times 8 would be 16, so this would be 16/3. And then minus, okay, so 2 squared is 4, 6 times 4 is 24, and then 24 divided by 2 is 12, so minus 12, plus the 8. Minus, parenthesis, now I'm putting 0 in, right? So this would be 0, minus 0, and then plus 0, right? So that'd just be 0. Okay, so what is sine of pi over 2? Well, it's 1, right? So this would equal 16 over pi minus, and what's sine of 0? Well, sine of 0 is 0, right? So that's just, this whole thing right here is just going to be 16 over pi. And then minus, okay, and then this is going to be 0, so we're not going to have to worry about this part of it, okay? So it's going to be minus 16/3 plus 12 minus 8. Now, you could have combined these and then taken the opposite of it, right? Okay, so this is going to be 16 over pi, and I just realized you can't see it, okay? 16 over pi minus 16 thirds plus 4, right? Okay, so common denominator, okay, if you stopped, okay, honestly, if you stopped, what I would do is if you were doing this by hand, I would stop right here, okay, because that's a numeric answer and they're going to count it right, okay? Even if you don't simplify it, it's a numeric answer, so it's going to be counted as right, okay? All right, so I'm going to go all the way, okay? So we need the denominator, we need a denominator of 3 pi, okay? So this becomes 48 over 3 pi, because that's the same as 16 over pi. This one I need to multiply by pi over pi, right? So this is going to be minus 16 pi over 3 pi. And then plus, and then this one I need to multiply by 3 pi over 3 pi. So that'd be plus 12 pi over 3 pi, because that's still 4, right? Okay, so these two I could combine, okay? And so my area would be 48 over 3 pi, and this would be minus 4 pi over 3 pi, which would give us an answer of 48 minus 4 pi all over 3 pi, okay? And that's the area of R, okay? Again, on the AP exam, you don't need to go this far, okay? I would either stop right here, or at the very, at the most, I would go to right here. I wouldn't go any further, okay? Honestly, okay? It's just a different test, and they're not testing you on can you add and subtract, multiply and divide, okay? They're not testing you on that, okay? So they don't really care about that, okay? They're gonna assume you know how to do that, all right? Okay, let's go to part B. So for part B, okay, they want you to write, but do not evaluate, okay, an integral expression that gives the volume of the solid generated when this region R is rotated about the horizontal line y equals 4. So if you draw a horizontal line right here, y equals 4, right? Okay, this is y equals 4, okay? And now if we go from that line that we're rotating around, right? If we're rotating around that dashed line, okay, then from that line, the furthest curve away is the f of x function, right? So that's going to be my big R, okay? And then to the closest function would be this one, and that would be little r, okay? And it's going to be top minus the bottom, okay? So top minus bottom. This is going to be a washer, okay? We're going to use the washer method, okay? So let's go ahead, and I'm probably going to switch back and forth between this diagram and the write-up, okay? All right, so let's go to our paper. Okay, so the very first thing I want to do is I want to establish our big R, our big radius, right? Okay, so when we do top minus bottom, the top is the horizontal line 4, right? And the bottom is f of x, okay? So big R is going to be 4 minus f of x. Or cleaning it up, it'd be 4 minus, and then f of x is the 2x squared. It's the parabola one, right? So 2x squared minus 6x plus 4, right? We could clean that up some more, okay? Because we're going to take 4 and we're going to subtract this, right? So this would be 4 minus 2x squared minus, or plus 6x, sorry, plus 6x, and then minus 4, right? So this 4 and the minus 4 are going to cancel out. So our big R is negative 2x squared plus 6x. And by doing the top minus bottom, that guarantees that this R is going to be positive, okay? All right? Okay, now little r. What's little r? Okay, so that is the top curve, which is r, or 4, right? And then minus g of x. Okay, so that'd be 4 minus 4 cosine of 1/4 pi x. And there's nothing you can do to combine that, so that's it. That's our little r, okay? Now remember, we're creating a disk, right? Which is the area of a circle. And then we're going to make infinite thicknesses, right? And that's going to be my dx, right? So we need to do, what we're going to do is we're going to integrate. The general idea of this is we're going to integrate from 0 to 2, okay? And we're going to take pi big R squared, okay, dx, and then minus the integral from 0 to 2 of pi little r squared dx. Now, it's not normally written this way, okay? But what we're doing is we're finding this big disk and we're removing the little disk. That's what this does, okay? So really what we could do is we could write this as one integral, and we could also factor out pi, right? Okay, so this is really, and if you started with this, you'd be fine, okay? So this is really pi times the integral from 0 to 2 of big R squared minus little r squared dx. Okay, so that's really all we have to write. Okay, so this big R is the negative 2x squared plus 6x, and we need to square that, right? Because remember, this is the area of the circle, and this is the thickness. So when we multiply these, we're going to get volume. Okay, all right. So this would be equal to pi, the integral from 0 to 2, our big R, which is negative 2x squared plus 6x squared, minus our little r, which is 4 minus 4 cosine of 1/4 pi x, close the parenthesis for the cosine, and then close the parenthesis for the little r, and we need to square that, and then dx, right? Okay, and that's it. We're done. Okay, you don't need to clean up or anything. That's it. That would give you the volume of this solid that's generated by rotating r around the line y equals 4. Okay. All right, that's it for part B. Let's go to part C. So for part C, they're telling you the region R is the base of a solid. So this is the bottom, okay, of a solid. For this solid, each cross section perpendicular to the x-axis is a square, okay? And write, but do not evaluate an integral expression that gives the volume of the solid, okay? So this is cross-section areas, okay, that we did when we did area and volume, okay? And what we're doing is, this is it right here. And this is a side of a square, and the side, and then this is the base of it, so this is the bottom of it, and so it's coming up off the paper like straight up, and this is one side of that square, and then we have a side that comes straight up off the paper. I wish you could see that, right? Okay, and so the area of this would be side times side, right? And we can get the side by taking g of x minus f of x, okay? So that's kind of the idea behind it. Okay, I'm gonna label this S right here, okay? So that's my S, that's my side, okay, for my square. All right, so let's go to our paper and let's do this. Okay, so my side, okay, so my side length would be g of x minus f of x. Because I'm doing the top minus the bottom, right? But that would mean g of x, which is the 4 cosine of 1/4 pi x, and we'd have to subtract, okay, f of x, which would be 2x squared minus 6x plus 4, okay? So then that would become 4 cosine of 1/4 pi x minus 2x squared plus 6x minus 4. Okay, and that's the side length. Okay, so what's the area? Now this is a square, right? So the area in terms of x, okay, a of x would be, okay, and it would be 4 cosine of 1/4 pi x minus 2x squared plus 6x minus 4 quantity squared, okay, because it's a square, right? So it's going to be side times side, which is side squared. That's why I'm squaring this side length, okay? All right, so the integral expression for volume, so the volume would equal the integral from 0 to 2 of a of x, and that would be the area of it times the thickness of it, which is my dx, okay? All right, so then that would be, the integral expression would be the integral from 0 to 2 of 4 cosine of 1/4 pi x minus 2x squared plus 6x minus 4, close the bracket, squared, and then dx. And that would be the volume of the solid that they're describing in part C. Okay? All right, you guys, so that's it for today. All right, you guys take care, and I'll see you on Monday.